Today we are solving a Leetcode question, which is balanced binary tree. In this question, we are given a binary tree, and we have to check if the height of the tree is balanced or not. So the height of the tree is balanced if its two subtrees is height is less than or equal to 1. If it is greater than the 1, then it is not height balance. So if you take an example, like if we have 3, 5, 7, 8, and 10. If you find height, basically if you find height of the trees, right? If you find the it's this subtree height and this subtree height, then what is the height? Height is equal to, it is 2 and this is 1. So 2 minus 1 is 1, which is greater than equal to 1, then it is correct. If it is greater than equal to 1, then the height is balanced. If, like if we take another node, like if we take here 11, now what is the height of the left subtree? Is 3. What is the height of right subtree? Is 1. So 3 minus 1 is greater than equal to 1. No, it is not. Then it is not height balance, right? So how to solve it, right? Like we have to find the height of the left and right subtree. So basically we will, like, so how to approach it, like first we will create a function and find the left subtree height, right? Left subtree height, we will pass the left subtree height, right? We will pass the root left, right? So if we pass the left subtree, what is the height of this subtree? It is 1, right? It is 1, and it is also 1, right? So it is balanced, right? This part of the tree is balanced, so we will return true. So this return true, right? So if we take, if we find the, now if you find the height of the this subtree, this whole subtree, what will be the height of this whole subtree? Is 2, right? If we move to the right part of the subtree, right, we find the left part of the subtree, and if we find the right height of the subtree, and what we'll do, we'll move here and find the height of subtree, which is 1. So this is 2 minus 1 equal to 1. Like if we check here, if is 1 minus 1 is greater than equal to 1, 2 minus 1 is greater than equal to 1, right? It is, we take a absolute of it, right? So this is a height balance tree. Like if we take another node which is 9 and find out if it is balanced or not, right? Now if we pass root left, we will find the height of it, right? If we find the height of this subtree, right? Find out this subtree is, here it is null, we move left to left to left to left, right? And we find the height of the subtree, and it is 1, right? Then if you move forwards, then it is, then if you don't have any right, so this is balanced. So 1 minus 0 greater than equal to 1, right? If you take here 2 and this is here is 1, so 2 minus 1 is also balanced. So if you move further, this is 1 and this is 1, this is 3 and this is 1. So 3 minus 1 is not greater than equal to 1, right? So this is not height balance. So this is not a height balance tree. So if you move to the code, so if we are taking a So we are taking check if our root is null or not. If it is null, we basically return for true because it is already height balance, right? So we will take a helper function, right? And we will pass here root. So we create a function and we pass argument as root. So for initially base case is if our root is equal to null, and we will basically return true, right? Then what we will do? What we will do? We will create a height function. Which what we will do? We will create a height function which is checking its height. Take it height and passing here basically root, and base case is if your root equal to null, then we will basically return 0 because the height is when root is not there, then height is basically 0. Then what we'll do? We'll take out the maximum of the left part and the right part, right? So this is how we find the height of the tree. So if take a left height which is height of root dot left, and we will take a right height of root dot right. Now here we check if our absolute of left height minus right height is greater than 1 or not. If it is greater than 1, then what it means? It means our height balance, whether height of the tree is not balanced. So then basically we will return false, and we will, if it is not, we will move further to check its left part, and we will take out the left and right part with the AND operator. If it is true, if in any case it return false, then it will return false in every case because of the AND operator. If we run this code, so our solution got accepted, and we have done the problem on the binary trees.